How are magnets made? The production of magnets is a fascinating process that requires a blend of cutting-edge technology, meticulous craftsmanship, and stringent quality control measures. From the pulverization of raw materials to the final magnetization, each step in the manufacturing process plays a crucial role in ensuring the performance and reliability of the end product. In this exploration, we delve into the intricacies of magnet manufacturing, uncovering the secrets behind the creation of these indispensable components of modern technology. Join us as we unravel the complexities, challenges, and innovations that define the journey from raw materials to powerful magnets. Numerous techniques exist for magnet production, with powder metallurgy emerging as the predominant method. In this approach, the raw material composition undergoes pulverization into fine powder, followed by compaction and heating to induce densification through liquid phase sintering. Consequently, magnets produced via this method are commonly referred to as sintered magnets. How to produce SMCO and neomagnets. Suitable raw materials are melted under vacuum or inert gas in an induction melting furnace. The molten alloy is either poured into a mold, onto a chill plate, or processed in a strip caster, a device that forms a thin, continuous metal strip. These cured metal chunks are crushed and pulverized to form a fine powder ranging from 3 to 7 microns in diameter. This very fine powder is chemically reactive, capable of igniting spontaneously in air, and therefore must be protected from exposure to oxygen. There are several methods for compacting the powder, and they all involve aligning the particles so that in the finished part, all the magnetic regions are pointing in a prescribed direction. This is where powder is placed into a cavity in a tool on the press, and punches enter the tool to compress the powder. Just prior to compaction, an aligning field is applied. The compaction freezes in this alignment. In axial, parallel pressing, the aligning field is parallel to the direction of compaction. In transverse, perpendicular pressing, the field is perpendicular to the compaction pressure. Because the small powder particles are elongated in the direction of magnetic alignment, transverse pressing yields better alignment, thus a higher energy product. Compacting powder in hydraulic or mechanical presses limits the shape to simple cross-sections that can be pushed out of the die cavity. A second compaction method is called isostatic pressing, wherein a flexible container is filled with powder, the container is sealed, an aligning field is applied, and the container is placed into the isostatic press. Using a fluid, either hydraulic fluid or water, pressure is applied to the outside of the sealed container, compacting it equally on all sides. The main advantages to making magnet blocks via isostatic pressing is that very large blocks can be made, and since pressure is applied equally on all sides, the powder remains in good alignment, producing the highest possible energy product. Pressed parts are packaged in boats for loading into a vacuum sintering furnace. The particular temperatures and presence of vacuum or inert gas is specific to the type and grade of magnet being produced. Both rare earth materials are heated to a sintering temperature and allowed to densify. SMCO has the additional requirement of a solutionizing treatment after sintering. After reaching room temperature, both materials are given a lower temperature tempering heat treatment. During sintering, the magnets shrink about 15–20% linearly. Completed magnets have a rough surface and only approximate dimensions. They also exhibit no external magnetic field. Finishing sintered magnets receive some degree of machining, which can range from grinding them smooth and parallel, OD or ID grinding, or slicing block magnets into smaller parts. The magnet material is both brittle and very hard, Rockwell C57-61, and requires diamond wheels for slicing and diamond or special abrasive wheels for grinding. Slicing can be performed with excellent precision, often eliminating the need for subsequent grinding. All of these processes must be conducted very carefully to minimize chipping and cracking. In some cases, the final magnet shape is conducive to processing with a shaped diamond grinding wheel, such as arcs and bread loaves. Product in approximate final shape is fed past the grinding wheel, which provides the precise dimensions. For lower volume manufacturing of these complex shapes, EDM machining is commonly used. Simple two-dimensional profiles, EDM is faster. The magnet manufacturing process requires the application of advanced technologies and deep understanding of materials and manufacturing processes. Investing in research and development helps improve production efficiency and create higher quality products. The quality of magnets depends on tight control of the production process from raw materials to the final product. Implementing an effective quality control system ensures that each product meets the highest quality standards. The magnet manufacturing process may involve various risks to workplace safety and environmental impact. Implementing safety measures and environmental protection is essential to ensure a safe working environment and protect the environment. The magnet manufacturing process requires the ability to manage risks and flexibility in addressing unforeseen issues. Applying risk management measures and flexibility in the production process helps minimize risks and ensure continuity in production. Optimizing production efficiency and minimizing costs are important goals of the magnet manufacturing process. Using modern technologies and production processes helps improve efficiency and reduce waste, thereby optimizing production costs. From the magnet manufacturing process, we can learn about quality management, workplace safety, environmental protection, and flexibility in production management. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.